A conical pendulum is constructed with a string of length L and a ball of mass m. The ball is swung in a horizontal circle such that the string makes an angle theta with the vertical, as shown in the diagram. In terms of L and theta, determine the radius of the circle swept out by the ball. So we're trying to find this length here. We see it makes a right triangle where L is given and theta is given, and we want to find the opposite side. So sine theta is equal to opposite over hypotenuse, and so the radius is L sine theta. Now we want to sketch all the forces acting on the ball. So I'll do that in red. We have the tension from the string, and we have the force of gravity pointed straight down. Notice that my force of gravity is smaller than tension. My y component of the tension would equal to the force of gravity, and my x component of the tension is going to provide my centripetal force. These are components of tension and should not be drawn on this diagram. To find the speed of the ball, we'll have to look at the sum of the forces in the x direction and the sum of the forces in the y direction. In the x direction, we have the x component of the tension, which is t sine theta, and that's providing our centripetal force, mv squared over r. But we can't have tension in our answer, and so the forces in the y direction will help us get rid of the tension. So in the y direction, we have t cosine theta upward and mg downward, and the ball's not accelerating in the vertical direction. So t is equal to mg divided by cosine theta. We'll plug that in up here. So mg over cosine theta sine theta equals mv squared over r. The m's can go out. Sine over cosine is tangent. I'll continue over here. So I have g tan theta equals v squared over r. So v is equal to r g tan theta, all under a radical. And we're not allowed to have r in our answer, but the radius we found on the last slide was L sine theta. So now we're supposed to find how long it'll take the ball to do 10 laps. So v is equal to d over t. The velocity we know from before is rad L g sine theta tan theta. The distance it has to go is 10 laps times the circumference of the circle, which is 2 pi times r, and r is equal to L sine theta. And so we just have to get t by itself. T is going to equal, the top is 20 pi L sine theta, and the bottom is rad L g sine theta tan theta. All right, this is a perfectly acceptable answer, but there are some things that we can simplify a little bit here. On the top, I could write this as 20 pi rad L rad sine theta rad sine theta. You can see that doesn't change the top at all. Rad L times rad L is L, and rad sine theta times rad sine theta is sine theta. But what it helps me to do is cancel out with one of the rad L's in the bottom. One of these sine thetas go out, one of these rad L's go out. I end up with a time of 20 pi rad L sine theta over rad g tan theta. And that's a pretty good simplification. If you want, you can also write tan theta as sine over cosine, and then one of the signs would cross out. And so that would be 20 rad L cosine theta over rad G.